Students, these days we are learning uh, different types of applications of derivatives. No? So we have also learned how to apply how to apply derivatives to know the tangent of a function, at a given point, and also we have learned how to find out the approximate value of a function at a particular point. By applying derivatives we can find out the value of a function at a particular point. In our today's discussion we will be taking some other applications of derivatives, like so before I talk about the other applications of derivatives, I would like to clear these points, though I have given some explanations regarding these points. Once again, just I would like to take those points. What we call a turning point or a critical point of a function. Turning point or critical point of a function means, just look at this graph. Here the graph of the function f of x is turning like this. You see, at this point, as it reaches this point, then after that it start decreasing. Again, after it, so it is decreasing towards this point. But after this point, again it starts increasing. So these points, they say this point is C1 and this point is C2. No? At C1 it has turned from increasing to decreasing. No? The function's value was increasing. Up to C1 it was increasing. At C1 it has again switches to decreasing. So it decreases, and at C2 it stops decreasing and it starts increasing. So such points are called turning points of a function. Turning points are called critical points. Okay, dear students? So turning points or critical points are those points at which the graph changes from increasing to decreasing or decreasing to increasing. That I would like to say in this. Now one point is just see, at these points, at these turning points, if we have the slope of the function, if we draw the slope of the function, what will be that if we find out the slope of the function, that means derivative of the function at these points, their derivatives will be 0, because the tangent that you will draw, it will be parallel to x-axis. This is x-axis. No? So the tangent that you will draw at these points, they will be parallel to x-axis. That means the tangents will make no angle with the x-axis. That means it makes 0 angle. If 0 degree it makes, that means slope will be 0. That means at the turning points, the slope of if the function is continuous function and that it is differentiable function, means the function is differential, you can find out its derivative, because there are some functions which you can't of which you cannot find out the derivatives. One example I can give you, just you see, look at the graph of this function. Just you see here, this function, its graph is actually it is decreasing at x equal to 0, it is decreasing to 2, but after that again it is increasing. But this function is not differentiable at x equal to 0, because at x equal to 0, at this point you can't draw a tangent. That means you can't find out its slope at x equal to 0. So the function is not differentiable at x equal to 0. So this is not a differentiable function, but it has got a critical point. The critical point is what? X equal to 0, because at 0, x equal to 0, it turns from decreasing to again increasing. Are you understanding? So as it is going towards the 0, then it was decreasing, but at 0 again it starts, after 0 towards the right hand side of 0, it starts again increasing. So there are functions like this which is not differentiable, but it can have critical points. So critical points or turning points, as I told you before, that critical points or turning points are those points at which the graph changes its direction. Means if it is coming from decreasing to increasing, or it is decreasing to increasing to decreasing. So those points are called turning points or critical points. Okay, dear students? So now here, just you see one more thing I would like to say. So you see here, now if we draw the tangents at different points, that is, since the slope of this tangent at this point it is equal to 0, slope of the tangent is 0, then what will happen at this point? If we take the slope at this point, just you see, if we take the slope here, slope of this tangent will be what? Less than 0 or not, because it is going down, or no? So the tangent is towards, so that is f dash x here, it will be less than 0. Again f dash x will be less than 0. In all these points f dash x will be less than 0 up to here. But at this point f dash x is, m means what? Slope. Slope is actually f dash of this point. What is that? C2 is equal to 0 at this point. So this point is C2. So at that point this slope is 0. But after that the slope will increase. The slope, because the graph will be steeper and steeper. Steeper means the slope, the gradient, that means m, it will be greater than 0. So dear students, did you notice, as after the critical point, after the you can say the turning point, let us say turning point, after the turning point the slope will be either decreasing, no, the slope of the graph will be either decreasing or increasing. If it decreases, that means if the slope of the slope of the function decreases, means it is less than 0. That means when the slope will be here, the slope will be, the f dash x will be less than 0. No, here at this point it will be less than 0. Suppose this point is something, say C3, then f dash C3 will be less than 0. So if we take here f dash x, that will be greater than 0, because up to here it was going on increasing, so it was greater than 0. And as it reaches this C2, C1, no, at this point the slope becomes 0. After that it will again decrease only. So dear students, you see how derivative is interesting to apply to know the critical points. That means if we know the zeros of the derivative, zeros of the derivative means at which the derivative becomes 0, then we will be able to say the critical points. And considering the considering the turning points, better to say turning points. So if we can find out the turning points C1 or C2, we can find out these points. How to find out these points? Just you take the derivative of the function. First step will be take the derivative of the function. Second step will be the derivative of the function you equate with 0 to know the zeros of the derivative. To know the zeros of the derivative, you equate this function to 0. This function you write equal to 0, so that you will know for which values of x the derivative is 0. So those values of x, suppose x is giving you a as a C1, no, or C2, all these will be called turning points. All these will be called turning points. So because of these turning points, the derivative of this function will decrease to will decrease, or it will after this point it may decrease or it may increase. So these are the points which are turning points. So we have to know the turning points. So derivative is an interesting part. You can know the turning points of a graph or turning points of a function. So now we have understood that the turning points or the critical points are those points at which the graph, the value of the function, it either after these points the value of the function either increases or decreases. See, so this is a point, say C1. At this point the slope of the tangent, slope of the graph, this will be equal to 0. Here the slope will become 0, the gradient will become 0. Here also there is a point, say here C2. At this point, if we draw the slope to the function, then we'll get that slope also is equal to 0, m is equal to 0 here. So this is a turning point, or this is a you can say critical point, no? So this is also a turning point. Another turning point you can see here. So another turning point here. This is also point C3, also a turning point, because here the slope will be 0. Here the slope of the graph will be 0. Here m will be equal to 0. So dear students, you might have noticed here that if we have tangents here at this point, suppose before this point C1, suppose at this point C2, C4, suppose if I take the slope, what will happen? This slope will be greater than 0 because it is going upward. The graph is going increasing and increasing. So this value will be greater than 0. Then here the slope will be, means the rate of change of the function, no? Rate of change of the function at this point C4 will be greater than 0. The rate of change of this function after this point C1, it will be less than 0. So that is the advantage of knowing the what called slope of a derivative of a function. Using derivative, we can say after which points, the critical points which are, we can easily find out using derivative, because just you take the function. First of all, step number one, just you take the function and take its derivative. Okay, and second step is to know the critical points. You take that function, the derivative of the function equal to 0, and you will know the zeros of f dash x. You will know the zeros of f dash x. That means the values of x for which it may be C1, C2, no, or C3, all these points you will come to know if we write f dash x equal to 0. Then these are critical points. Now to know whether the function gives maximum value at these points or minimum value at these points, you can easily know if suppose f of C1, if f of C1 is a value which is, it means f dash C1 is a value, suppose, which is greater than 0, suppose. Just for one example I am just saying, suppose here at this, you see, at this C4, what will be the value of this f dash C4? Just you tell me what will be the value of this f dash C4. It will be obviously greater than 0, because at this point it is f dash C1 is 0. M is equal to 0 at this point means it is f dash C1 is equal to 0. Then is before C1, very close to C1, there is a point C4, suppose, very close to C1. Very close to C1, C4 is very close to C1. Think like that, but towards the left hand side of C1. I am talking about a point, let us say this is C4, okay? So f dash C4, which is very close to C1 and towards the left hand side of C1, at that point f dash C4 will be greater than 0. And very close to C1 towards the right hand side of C1, suppose there is a point C5. Say it is a point here C5. It is a point here C5. At that C5, the slope of the function will be what? That will be less than 0. See, f dash C5 very close to C1, but towards right hand side of C1, and that is less than 0. If it happens, we can say C1 is the point of local maxima. Point of local maxima is that point at which just close to that point, that particular point, towards left hand side of that point, the derivative of the function at that left hand side of point will be greater than 0, and derivative just towards the right hand side of that point, derivative of the function very close to that point at a particular point towards right hand side of that point will be less than 0. If this happens, then we can say the point C1 is a point of local maxima. Local maxima is determined that way. Once again I am saying to you, just try to understand from this graph as you see. So here C is a critical point, means turning point. At C, the slope of the function is equal to 0. No, at C it is equal to 0. Then just towards left hand side of C means, I mean to say, suppose H is a this part is suppose H. That means this point will be C minus H. At that f dash C minus H, if it is greater than 0, what I mean, H, you understand, no? H is this portion, H, very little, towards left hand side of C. Since here at this point slope is 0, I am talking about this point. At this point, that means I mean to say this point, okay? Here at this point C minus H, this point is C minus H. just you see, this point is C minus H. H is a very small quantity. As you know, it is just greater than 0. H is just greater than 0. So towards left hand side of this C, this is a point C minus H. At that C minus H, the F dash C minus H is greater than 0. Okay. And towards right hand side of this C, there is a point, say, C plus H. This is again H, suppose, quantity. And this point is, suppose, C plus H. H, as I told you, H is greater than 0. And at that point, the derivative of the function here, at this point, the derivative of the function, this is F dash C plus H. And that is less than 0. If it happens, then you can say point C is the point of local maxima. Point of local maxima, I have said. Okay, dear students? If it is like this, suppose this is the function's graph. Okay? And here is a turning point C. This is the turning point C. So at this point, the slope is 0. Slope of the graph is 0 here. Okay. Now, suppose there is a point here towards the left hand side of this C. This is a point that is C minus H. Suppose this point is C minus H, because I have taken this distance as H. H is a very small quantity, it's just greater than 0. At this point, C minus H, the slope of this function, here at this point, the slope is suppose less than 0. Slope is less than 0, means F dash C minus H is less than 0. And at this point, at C plus H, this point is C plus H, because this is a small quantity H I have added here. So at this point, C plus H, the slope of the function, this is the tangent to this function, tangent to this graph at this point, and the slope of this is F dash C plus H, and that is greater than 0. If it happens, so then we can say the point C is point of local minima. Local minima, we can say, means before C the slope is less than 0. Less than 0. Before C, the slope of the function is less than 0. And after C, the slope of the function is greater than 0. It happens. Then we can say this is a point of, point C is a point of local minima. So point of local minima is that point at which before that point the slope of the function is less than 0. After that point, the slope of the function is greater than 0. If the C is a point in the given interval, it is an included point of the given interval. What is the interval? There is a point, the interval is C minus H and C plus H. In this interval, point C lies, no? And we are talking about the local minima. That is, point C will be called local minima if at C minus H the slope is less than 0, and at C plus H the slope is greater than 0. We say the point C is point of local minima. Okay, dear students? Dear students, from this discussion what we can say? That means after the turning point, if that means the function has got local maxima or local minima, after the turning point, the slope will be either greater than 0 or less than 0. Got the idea? That means the functions, sign of this f dash x will change after the turning point. Sign of f dash x will change. Sign of f dash x will change. After when? After the turning points. F dash x you see here, this is f dash x, f dash c4 greater than 0 means it will be positive. F dash c5 less than 0, that means it will be negative. So that means at c5, just you see here you see, C is the turning point, and f dash c minus h is greater than 0. Positive, that means. and f dash c plus h less than 0. Less than 0. That means it will be negative. So after c, the sign of the derivative will be negative, and before c, the sign of the derivative will be positive. So that is turning point. That is turning point. If the function is continuous and the function has got local maxima or local minima, why you call it local? Because local means within a certain interval only we are talking about. Because a point can a graph can have, a function can have so many maximum points or so many minima points. Like just I am showing you here, just you see in the graph. So dear students, in this graph you see the function here at this point it is a maximum value. Again it is having a minimum value here. Again it is having a maximum value here. Means the function is giving another maximum value here. So there can be so many maximum values here for the function. If we talk about a particular maximum value within a certain interval only, then we call it a local maxima. That means this C1 is a local maxima within this interval C1 minus H, in the interval C1 minus H and C1 plus H. In this interval only C1 is a maxima, point of maxima, and C3 is a point of maxima in the interval C3 minus H and C3 plus H. In this interval the C3 is included. So then in that particular interval this is giving a maximum value. The function's value at this point fc3 is maximum in the interval C3 minus H, C3 plus H. In the open interval C3 minus H and C3 plus H, this fc3 is giving you the maximum value. Then maximum value of the function. The maximum. So that's why you can call it a local maxima only. Local maximum. That means there will be some another term for maximum value again or minimum value again. So this is a local minima only. Means because within this interval only, this is a minimum value within a particular interval. So this point C2 belongs to the interval C2 minus H and C2 plus H. In that interval it is the minimum value. So we can call it a local minima. Okay dear students. So what we have understood here, this f dash x, the sign of this f dash x will change at the turning points. Sign of the f dash x will change at the turning points. So dear students, keep that point in mind. At the turning points, it can be greater than 0 or it can be less than 0. Okay dear students. So now you get the idea from this discussion that if it is greater than 0 towards the left hand side of that particular point, and if it is less than 0 towards the right hand side of that particular point, that point is a point of local maxima. If it is opposite of this, I mean to say it is just like this. Suppose at C, before C, f dash c minus h is less than 0, and after C, that is at f dash c plus h is a value which is greater than 0. In that case we will say C is local minima. Okay dear students. Now look at this graph dear students. Here you see, if we find out the derivative of the given function, the function is f of x equal to x cube. If we find out the derivative, then what we will get here, that is f dash x is equal to 3x square. Think dear students, any input you give here, 0 or 1 or 2, any input you give here except 0 at 0, in all other places, suppose I take minus 1, what will happen minus 1? 3 into minus 1 square, that will be 3 only, greater than 0. Or if I take here plus 1, then also it will be greater than 0. So if I take here 0, then it will be equal to 0. That means 0 is only the point, x equal to 0 is only the point at which the value of the derivative of the function is 0. But before 0 and after 0, at all points the this f dash x will remain all the time greater than 0 only. Then its sign is not changing. That is f dash x, it does not change its sign. It will be always for all values of x except 0, it will be greater than 0, or you can say equal to 0. At x equal to 0, it is equal to 0. Then this point, this x equal to 0, is called a point of inflection. Dear students, just look at this point of inflection. Point of inflection means the point at which this is a point at which the sign is neither negative nor positive. That is called point of inflection. Okay, dear students. So the point before it and after it, the sign of the derivative of the function does not change. It remains same. Then we can say that point which tells us about the place at which the sign will be just neither positive nor negative. That is point of inflection, dear students. Okay. Now suppose in a closed interval, suppose here this is the graph. Okay, this is the graph, and within this closed interval, at this, say this is A and this is suppose B. Okay, in the closed interval A comma B, in the closed interval there are so many points at which the graph changes its direction. See, at this point, this is one critical point, turning point, this is another turning point, another turning point, another turning point. There are so many turning points. So that means in a closed interval, if there are turning points, so many turning points, then we talk about the absolute maxima and absolute minima. Absolute maxima means the maximum value of the function within that closed interval. Means we need to find out all the turning points. First of all, we need to find out all these turning points. Say it is, say, C, D, E, F, Z. At this C, D, E, F, Z, this E is giving the maximum value. At E, the value of the function will be maximum. Then we say this is absolute maxima. This point is a point of absolute maxima, and this value of the function will be called absolute maximum value. Absolute maximum value means this is also a maxima, 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 this is also a maxima. But we are talking about this closed interval. Inside this closed interval, there are so many local maxima, but among these local maxima, one is there which is the maximum. So that is called absolute maxima. And this is minima, this is minima. So among the maxima, 1, 2, 3, this is the maximum one, means the highest one. We can say this point is the point of absolute maxima, and this value of the function, that is f of E, will be called absolute maxima value of the function f. Okay, because this is also maximum, this is also maximum, this is also maximum, but among these three, this is the highest one, greatest one. Okay, dear students, then that means when a function will be defined in a closed interval, then we need to find out the endpoints. First of all, endpoints of the interval and the turning points of the interval. And in those turning points, at which point the value of the function is maximum, that point you have to consider. Okay, dear students, as a point of absolute maxima. Or absolute minima also similar way. Suppose this is a minimum value, this is also a minimum value. Again, there may be another minimum value. Say this is also a minimum value, or this is also a minimum. Among these, which is giving the smallest, this is the one. Suppose I am just saying, or this is the one. Then we can say this is the absolute minima. There are so many minimum value, 1, 2, 3, 4. Among these, suppose it gives you the minimum value, lowest value among these values. Then this point will be called absolute minima, point of absolute minima, and this height will be called this is absolute minima value of the function at this point D. That is, FD will be absolute minima value. Okay, absolute minimum value. Dear students, did you understand? So today we have discussed about turning points or critical points, point of inflection, point of local maxima, point of local minima, absolute maxima, absolute minima. So with the help of derivatives, we can determine which are the critical points or which are the turning points, what is a point of inflection. We can find it out because at the point of inflection the sign of the derivative will never change. Means throughout the whole graph the sign of the derivative will not change except at the point of inflection. At the point of inflection it will neither show positive or negative. Point of local maxima we understood, point of local minima also, and absolute maxima and absolute minima. In our next class we will apply these all concepts in different problems. Okay dear students, we will learn how to apply these what called derivatives to know turning points. Okay, and have a nice day. Thank you.